Hi folks, this is Tom. Thanks for joining us here today. This is my prototype solar power module right here. The last couple years we've been making sure the technology works. Now it's time to package it and make it smaller and make it easier to work with. Before, you'd have to take the solar controller, the inverter, and try to hook everything up when we get to a fire. Now all we do is we hook two cables up, a positive and a negative here, and literally we take these plugs and we plug in solar panels and away we go. That's it. That's all we need to do. So this makes it a lot easier to get power once we get to an incident. For power here today, we have the 3 lithium iron phosphate batteries. These are 12 volt, 100 amp hour a piece. And the cool thing with these is you can pull these down to 99% depth of discharge, so they got 1% left in them. You really don't want to do that if you don't have to. They will go down to 80%, and it is recommended. At 80% depth of discharge, you still get 3,500 cycles out of this. Compare that to lead acid, where if you bring it down to 50% depth of discharge, you get typically 500 cycles out of the battery. So there's no comparison here. Plus, these things right here, they're light as can be. We can walk off with them, no problem at all. We can carry these to places we've never carried stuff before, or we would never consider taking lead acid. Also, if you notice here real quick, the negative is over here and the positive cable is over here. And what we're doing is hooking it up this way, we get a balanced power draw off of each of the batteries. If we were to put the red lead over here, you'd have it unbalanced. This would draw less, this would draw less, and this would draw more. And likewise, you'd have the same issues as far as charging it goes. Okay, let's go to the module here. This is strictly optional. This is the Victron 500A Smart Shunt. And what this does is, this gives us an automatic reading of what the battery is doing. I'm going to pull this up here, and there's our Smart Shunt. We're going to connect to it, hopefully. Uh-oh. Now comes the fun part. Let's try this. Well, I'm going to put the 6 zeros into it. Here we go. Now we'll see if it pairs. Fetching data. There we go. Whoops. It says the state of charge is 99%. And here's our trends. It's trending percentage there versus auxiliary input. Let's go back to status. Right here it says the battery voltage is 13.24, and we're pulling 6.27 amps from the battery, and we're actually pulling about 83 watts. And according to this, the time remaining on this is 20 hours and 9 minutes, but I believe we've set that incorrectly. I'm going to turn on the solar panel here. This module is sequenced so that you can turn both the batteries and the panel off. And what you do is when you show up on a scene and get this connected up, you want to make sure the panels are off. And the first thing you want to do is turn the battery on. The reason for that is that the MPPT 100/50 controller is a 12 volt, 24 volt controller. And if you turn on the panel first, it can confuse this and try to tell you that these are 24 volt batteries, and that doesn't work very well. So first thing you do is you turn on the battery here, and once you've done that, now we can turn this on, and let's see what this does for us. Pow, on we go. And pretty soon here it should start reading that we're actually putting power in. And okay, we'll go back to that. Actually, let's cut it. Let's start. Here we go. We flip the switch here, and now you can see that it says the battery's at 98% charge. We're at 13.29 volts, and it says that we have a net charging rate of 6.7 amps. Now you see it's going all over the place here, and it's dropping as the voltage is going up. Okay, let's go back over here. This year, we're using 2-gauge wire, and the reason we're using 2-gauge is that current loss is your enemy here on any low voltage, high current wiring. 2 gauge wire will handle anywhere from about 95 to about 115, 120 amps. So this is perfect. We're not going to try to pull more than 100 anyways. The negative lead, this is where we have the Smart Shunt in, comes over here. And right here on the positive side, we have a fuse right here. And all of the wiring internally here that doesn't go to a controller or an inverter is all number 2. The only time I've got any smaller wire, diameter wire than that is when I'm trying to go to the solar controller and the inverter. And the problem there is that these only go down to number 6. That's as big as they go diameter wise. So we've got very, very short runs of number 6 wire here going to ground and also going to power and also the panel feeding it. And likewise here in the inverter, we have a very short run of number 6 to this ground bus and a very short run of number 6 here to this power bus. Power comes in from the battery, goes here, goes to this switch, and you can turn it off right here, and then comes back out, and it feeds over to this master power bus right here. So turning that off turns the battery off, and if there's a catastrophic failure somewhere, the fuse takes care of it. Okay, on the solar panel end, Anderson power pole connectors here. This is 12 gauge Powerwerx zip cord. I've got 30 amp Anderson power pole connectors on here. So we can take the Harbor Freight panels of 57 325s and literally just plug them in. These have been modified by me. The original wiring on them was 16 gauge and not very long. And now they're 20 feet of Powerwerx number 12 gauge zip cord here. Much, much, much better arrangement. Just plug these in, and each one of these is 12 volts at about right around 5 to 6 amps, right in that neck of the woods. So these add up. As you can see here, I've got a warning sign here on the controller, 7 solar panels max. Because this is an MPPT, you actually get more current out than gets put in here. So literally 35 amps in at a higher voltage can give you the voltage you need at the battery at a higher current, almost 50 amps. And literally we've maxed these out here with 7 panels right at 700 watts, literally. And that's about as good as this can do. Right now we have a Victron, the Phoenix 12/500 inverter. These are bomb proof. This is literally the best inverter you can get on the market here, the Victron. The Phoenix series only goes up to 1200 watts, and more than likely what we're going to do this year is we're going to replace this 500 watter with a 1200 watter. We may also get a Renogy 2000 watt sine wave inverter. You always want pure sine wave, never square wave or a modified square wave. They just don't work that well. There's really not that much difference in them price-wise anymore. Coming out of the inverter, I have an outlet strip here, and right now what I've got plugged into the outlet strip is the kilowatts. What I'm doing is, I've got a couple of loads over here. I've got a LED light panel, and I also have a early 1960s All-American 5 tube type radio. If we check this out here, the tube type radio is pulling about 28 watts, and the light panel is pulling about 41 watts. These are neat because what you can do is you can check voltage. We've got 118.9 volts on that. We can also look at frequency, 60.1 cycles. That's right about where it needs to be. We can either check amps there, we can do watts, and we can also do accumulated kilowatts. Right now we've got 0.02 kilowatt hours, or there's 20 watts or 20 watt hours that have been drawn by the loads here. And it's neat. You can actually check this in the morning, check it at night, and check it the next morning again and see how much power has been drawn, and you can get an idea of what kind of loads you've had on this in the night. All of the Victrons here are Bluetooth. The Smart Shunt and the MPPT controller, they both have Bluetooth built in. That's one thing you need to do. If you go to order these and you want Bluetooth, make sure you get one with a Bluetooth installed. Up until a couple years ago, there was a $30 difference between them, and I got really disappointed when I saved the $30, got the controller in, and spent a half an hour trying to figure out how to make the Bluetooth work before I realized it wasn't a Bluetooth model. So check that out before you order. And the Phoenix here, you have to get the actual VE Direct Bluetooth dongle. We've got that here, and that works well. Right here, you can see with the Victron Connect app, which is free, the Smart Shunt is actually charging at 6.84 amps. It says the battery's at 100%. We have 182 watts coming in from the 200 watts worth of solar panel. So that's not bad. It's bulk charging. And right now it says we're putting 72 watts into the loads here. The inverter's operating and we have 13.28 volts in the battery. See, there's a little bit of difference there voltage-wise, but the bottom line is with the lithium iron phosphate, these guys run substantially higher voltage-wise than the lead acids do, so 12-volt equipment operates an awful lot better. A little bit of room left. The next step's going to be to miniaturize this to see if we can just crunch this in a little bit smaller and make it more easily portable. If we have a larger inverter here, it will occupy a larger footprint, and that may slightly offset any savings that we can get as far as making this smaller. I'm sure we can offboard the outlet strip here. That shouldn't be an issue. We could almost shrink this down by halfway and still have something that works fairly well here for us. So this is our version 1. We'll deploy this probably pretty quick here, and later on this year we'll hopefully roll out the version 2. Thanks for joining us.